Well, no, quite a little. What happened there?
I don't know.
They're quite an elusive animal, and yeah, I'm keen to talk to you all about them. All right, next. Perfect. So if you can see, they're very, very cute. So Phascogales are and are marsupial, so they have a pouch. Um, so Phascogales, they used to live all on the coast around of Australia, but due to habitat loss, deforestation, change of fire regimes, and cats or other invasive predators, they have declined, mainly due to the loss of hollow-bearing trees when they cut down forests. These little guys live in hollows. They're only very little, so they have to find a specific hollow that they can slide into that other predators can't get into, such as the lace monitor or owls. And they rely on this to nest in nightly. Every night they change, and also to have their babies, their young in those hollows. Um, so phascals are nocturnal. They primarily forage on invertebrates and bark, but they are opportunistic predators. So they will eat anything. There have been records of them eating birds, little birds, and their eggs. So they'll forage for anything that they can. Um, and yeah, we can also phascogales, I should mention, they are a threatened species in New South Wales and in Victoria. Um, they they're vulnerable on like the ICUN red list. So they are threatened, but they're not as threatened as some other animals. But who knows what the future for these little guys are. Change this too. So for my master's, I had four main research aims. So the first research aim is to try find the best method to detect these guys on cameras. So I'll talk to you more about that later, but I was trying to find the most optimal way to capture these little dudes. How big their home range is in New South Wales. So phascogales haven't been studied in New South Wales. I'm the first person to study phascogales in New South Wales. They have been studied in Victoria. That's where there's a decent population. But other animals kind of get the hold for research. So when I was choosing my masters, I was very excited to get to choose to do my master on phascogales because they're an animal that not many people have researched. So it's great to know a little bit more about phascogales. What trees they use? Like I said, they were living in they're living in a little oasis in the Hunter Valley. It was ironbark forest. So ironbark, you might have it around here, but it's a tree that you can't pull the bark off. It's really hard and rigid, and insects like to live underneath it. Yeah, yeah. So yeah, I have seen them around the area. So phascogales love those trees. So they live in ironbark spotted gum forests, and that is where there's quite a lot in the Hunter Valley. Well, there was quite a lot in the Hunter Valley, and that's what this forest they love to live in. Um, so I was trying to figure out what trees they were using if it changed from the phascogales in Victoria. And lastly, do phascogales recognize cats as predators? Like I said, um, invasive predators such as cats have affected phascogales, and phascogales are only little. They're about this big, including their little brushy tail, and they make easy prey. So I wanted to see if phascogales would recognize the scent of a cat. So now I'm going to talk to you about my first aim in my research project. So what is the best method to detect phascogales? So camera traps have been very successful in photographing phascogales, even though they are an elusive little small mammal. We've managed to capture them, but I wanted to find the optimal way and to standardize it. There was no method. People just putting up cameras and just hoping that they were capturing them. So I wanted to see if there was any difference between the methods. Um, So to do this, I might just do, yeah. So to do this, I set up two different cameras. I had the camera one and camera two. So camera one here is the horizontal camera. So the horizontal camera is the camera that was put onto a stake 1.5 meters up and facing towards the tree. That's a standardized camera that you'd use to capture arboreal mammoths. And then the second camera here, camera two, was a camera on an L bracket looking down. So this is the bracket attached to the tree, and it was looking down at the bait canister right at the bottom there. So both these bait canisters here, they have standardized bait, which is peanut butter, honey, oats, and Phascogales. It's a standardized bait for a reason. So what I found was that the vertical cameras actually detected more photos of Phascogales than the horizontal. I think that's a bit strange since Phascogales are an arboreal creature. They go up and down their trees. But what I found in my project is that they actually do spend a lot of time on the ground. So the horizontal camera here that was facing, that was very good at detecting arboreal creatures. So we got lots of Phascogales, gliders, sometimes a quoll. That's all we really got on those cameras. Whereas the vertical cameras, we got loads more species. So as you can see, the horizontal camera here got 9 Phascogales out of 11. So I had 11 cameras, and 11 of those cameras, 9 Phascogales from the horizontal cameras, and on the vertical cameras, 10. So just slightly more, not much of a difference. The main difference is the photos. So I got 10,471 photos in my study of Phascogales. So lots and lots of photos I had to go through and scroll through. Oh, I'm so sorry. And I had this site up for 110 days, so quite a long amount. And only two of the cameras towards the end broke down a little bit. One got water in it and couldn't be used again, and one, the camera, the battery faulted. It was probably up for too long and it didn't last. So the bait was changed every 14 to 16 days. So I'd go every 2 weeks to change the bait. My lovely volunteers helped me with that. And we'll change the SD cards, look through the photos. So in that, the horizontal picture photos of Phascogales was 2,837, whereas the vertical had 7,634 photos. So like I said, it was dramatically more photos on the vertical cameras than the horizontal. But that doesn't mean really anything until, oh, sorry, I explain why. We go to the next slide. This. So this is a fancy little diagram. I'll explain it to you. It's very, it looks very good, but it's very, very simple to understand. So here at the top here, that's the vertical cameras. The second one, the middle one of the red, is the horizontal cameras. And this one here is both. So this down here are the number of days. So that's 110 days at the bottom here. And up here are the 11 cameras, 11 sites. So there was 2 cameras on one tree. That was one site. So each of the colored squares is a detection. So one Phascogale, it could be multiple, but one Phascogale at least was detected on that one camera on that day. So as you can see, there's really not that much difference. And even this is a Phascogale that was texted on both cameras, so both the camera on either side, so the vertical and the horizontal on the one side is at the bottom there too. So these shaded ones here are the cameras that broke down. So this one's due to the water damage because this was done during La Nina. It was very rainy. So it was very hard to get out there. And the last 6 weeks of this study, I couldn't get out to my site to rebait. So these are just the ones that kind of happened to come on the cameras, just because of the flooding. I couldn't drive on there. So yeah, so you can see that there wasn't really that much difference in the detection rate of Phascogales on either camera. Down here is the occupancy. So you can see on the vertical camera, there was just slightly more detection than the horizontal camera. So even though there was way more images of Phascogales, doesn't mean that there was really any difference between the detectability overall. Go ahead to the next slide. I'm going to change the line too, sorry. So this one here is another little fancy graph. So this is just showing how long it will take to detect a Phascogale for a 95% confidence. So you want to, if you're putting out into the field, you put your cameras out and you leave them for an amount of days. That's why I'm trying to figure out what to optimize the amount of days to catch one Phascogale on the camera. Phascogales, like I said, they're a very elusive animal, and these here, that's for the sorry, let me just make sure I'm saying that right. Yes, the blue here, that's the horizontal, and the red here is the vertical. So it will take to get a 95% confidence, it will take 45.3 days on the vertical camera and 55.8 days on the horizontal camera to get confidence of capacity. So it's quite a lot. So if you're doing a massive site and you want to get one Phascogale, you've got to put your cameras out for roughly 50 days. So yeah, they're very hard animal to detect, and this is why I wanted to put this out to researchers so they are doing surveys. They can put it out for the optimal time as well as getting the right survey method to detect. All right, next one. This one here is another fancy little graph. So this is showing the residence time. So up here, you don't really have to worry about the bottom here. Is the residence time for 10 minutes, or for a delay for 10 minutes, 30 minutes, and 60 minutes. So a delay is from the first time you get a Phascogale, you wait 10 minutes, and that's a new Phascogale. The second one is you wait 30 minutes. And then the last one is you wait an hour. So the reason why we do this is so we don't catch the same Phascogale. So Phascogales, we do that in many studies. So Phascogales are animals that will wander around up and down the tree. We don't really want to get the same Phascogale because that doesn't really do anything for us. So we do a delay. So the delay is 10 minutes, 30 minutes, and 60 minutes. And the residence time was significant for the vertical cameras. So that means that the Phascogales stayed longer at the vertical cameras compared to the horizontal, which is really interesting. Like I said, for an arboreal creature, for an animal to stay right at the base of the tree is very interesting. So we actually had one Phascogale spend an hour. I watched it, scrolling through the pictures. She spent 1 hour trying to get the bait out of the canister. So it was very interesting. This was also during the time where Phascogales, the males die off. So Phascogales live for, male Phascogales live just under a year. They don't live very long. Females live can live for 2, maybe even a little bit longer than, but they tend to get a bit more riskier as they get older. And this time I had my cameras up. It was July to November, and July, August is when the males kind of die off. The majority of the Phascogale was in my photos were females. So they were having babies, they were breastfeeding, so they needed more nutrients. So I think that she was trying to get into the bait. She was trying to get nutrients to look after her baby. So that's what we kind of suspect, because females can be need more investments to look after the baby. So if need improving the more nutrients. That's just theory. Anyway, we'll go to the next slide. So, like I said, we found that the vertical cameras showed a lot more species than the horizontal cameras. Pretty expected, as in they're looking down, so we get more ground dwelling. But we also got a wedge-tailed eagle, as you can see there, which came and grabbed the bait. So you thought it was something cool. We got a spotted tail quail. This here is a squirrel glider, so even a boreal species can be detected on vertical cameras. And that's just a mum with a baby possum and a echidna, and I can't see the last one. Oh, that's the outland nightjar. So that's just the so all types of animals shot on the vertical cameras. So 32 species was on the vertical cameras compared to 14 species on the horizontal. So if you were doing a survey for phascogales as well as other animals, I recommend using vertical cameras. They not only detect the boreal species, but they can detect horizontal species. Oh, sorry, they can detect the terrestrial species as well, like kangaroos and stuff that you get there. So that was my first study. Head to the next one here. So the next part of my study was to determine the short-term home range of phascogales and what trees that they use. So to do this, yeah, I radio tracked 5 phascogales. So I got 3 boys and 2 females, and I radio tracked the females for let me see, for 13 to 26 days, and the males for 18 to 28 days. So the reason why I call this short-term home range is because it's not long enough to be considered their full home range. Phascogales have been really hard to do this with because they have such a short lifespan. They're also very difficult to catch in traps. Very, very difficult, and I'll explain why. But here are the collars. So that's the collar there. That's my hand. So the collars were this big. And they went around the little neck of the phascogale. So phascogales, the males weigh 300 grams. The females weigh 120. So they're not very deep. The boys were very chill. I could just keep him on my lap and do the collar, and he just sat there. That's their lovely tail there, the beautiful brush. And this is actually the collar that fell off one of my gliders. And I'll explain that a bit later too. All right, let's go to the next slide. So, like I said, phascogales are very difficult to catch. They're notoriously difficult to catch. So, I put up 6 nest boxes around the property. So, plus 3. So I chose trees that had really big diameters and they were iron bark, which is their preferred tree. I put them around 3 meters tall, so I was tall enough to be able to look inside the nest boxes. And I also used Elliott traps. This is a type B Elliott trap. I put one on the top of about 2 meters tall, so I could reach it, and then one on the ground. I found that phascogales chose the one on the ground more than the phascogales on the top, which is pretty cool. So Elliott traps. Phascogales are very, very clever. So when a phascogale gets caught into an Elliott trap, what they do is they turn around and they pull it down and run out. So very, very intelligent. So I had a lot of false triggers when I went to check my traps. And what I did to combat that is I actually tracked them throughout the night. So it was long nights for me. I would check the traps every hour. And I did this so I could release any animals that were in the trap, mainly a possum or anticlimbs. Those little rat mice things. They're native. They're all a lot in our traps. So just release them so it gives them more chance to catch phascogales. And yeah, that didn't really work. They tend to get trapped in the morning, which was a bit annoying. I had to spend all night doing that, and then I got sometimes a surprise, sometimes not. But I'd also recapture the same phascogales, the same 5 and have to keep moving them so I don't catch them because I wanted to see where they're going, and tracking them with a very high frequency. So I'll show you that in the next slide. It goes, if you get further away, the sound goes dimmer, and if you get closer to the animal, the sound beeps really high until you try pinpoint where the animal is. So these are the two main traps that I used. I also used a pipe trap, which is a PVC pipe in a J with the cap at the end, and it's a hole at the top. They can go into the tree and then get caught in there. Phascogales are smart; they can just climb right out of it. But I did capture one in there, so I tried to optimize as much as I could. Next slide. So these are the Phascogales in the nest. Nest boxes were the main way I caught my Phascogales. I caught 3 Phascogales in, I caught 2 Phascogales in a nest box, 1 in a pipe trap, and 2 in the other traps. Nest boxes were also the safest way to capture Phascogale. The Elliott traps, even though they can get out, sometimes the trap rebounds and they can catch their little tail. That's what I was most worried about when capturing Phascogales. I didn't want their tails to get caught. Luckily, none of our Phascogales experienced that. It just has been done in previous studies, and I just didn't want to replicate that. So I try my best to check them often as possible to avoid any of the Phascogales. But nest boxes were great. These are 3 different individuals, and they were the safest way. I just open them up, check them every day, and hope that new Phascogale in the box. They do reuse the nest boxes. The nest boxes are still up on the property, which is great. And the landowner updates me if he sees the Phascogale, if he checks them once over so often, which I love, that the landowner is so interested in all the animals in her property that she is happy to check. We'll go to the next slide. So we also had gliders. So loads of gliders were also in the nest boxes. These are squirrel gliders. So we have 3 squirrel gliders in this nest box, one of our radio tracked one there. So I did have 3 gliders in my study. I had 2 squirrel gliders and 1 sugar glider. So we'll go to the next slide. There we are. The reason why I haven't included them into my study is because of the low numbers. I was trying to compare if there was any competition going on between Phascogales and gliders. As they are in a small property, I thought maybe they could compete for hollows and one could push each other out from the hollows. There wasn't enough numbers to do that analysis, as I only got 3 and 5 Phascogales. But personally, from radio tracking them so often, there was a night that a Phascogale and a squirrel glider shared the same dead tree on one day, sorry. I'd radio track the Phascogale to the same dead tree, and they were both in there. I was so surprised. I was like, what's going on here? And then the next night, they just moved. So personally, I think that there's no real competition between species. I think they do use different trees, and I'll talk to you about that a bit later on. And yeah, that I found really interesting. There has been a study since I've done this that has looked at nest box usage by Phascogales and gliders, and also found no real competition between them. And that's what I think. I think what I've noticed in this study is that they rotate. So one, I don't know how they decide which gets which, but sorry, sometimes you go to the nest boxes and it will just be Phascogales each night, and then next month it will just be gliders, and then they just rotate. Like, it's very rare you see both a Phascogale and a glider next to each other. It does happen, but it's very rare. And I think the gliders rotate from each tree, and then they go in like a big circle, depending on the season, depending on what's flowering. And the Phascogales kind of just follow that. So here are some real cool videos of I don't know how you were going to do this. Oh, yes, that's it. So some phascogales, they stay very still. So when we're ready tracking them, we're trying to look for movement. These ones are the hardest ones to find. So two of our phascogales, they like to stay very still when we meet them. They just sat on the tree and stayed really, really still. Go to the next one. This one here. This one here. Sorry, a bit of technical. There we go. And some phascogales, most likely the boys, you could see them run. So you'd put the spotlight onto them and then they'd hop from tree to tree and you could see them running around. And it was very cool to watch that. Oh, thank you. Watch them do their natural behaviors. There was even a one night where a phascogale ran right past me up to another tree, like I wasn't even there. And then this is me releasing one of our phascogales that caught on the night. She was captured 3 times. She was a very happy girl. We knew her because she had a little kink in her antenna, which happened somehow. And then yeah, so phascogales, they're very hard to ready trap, not because they're hard to find, but because they always seem to lose their collars. So we tracked this girl. She had exactly 50 points. I tracked her for 50 days, and sorry, not 50 days, 25 days, and then she lost her collar, or something happened to her. We don't know. Sorry. And then same thing happened to our next girl, which you'll see in the next slide. There we go. After she finished mating with the boy also in this, both my radio tracked Phascogales, she disappeared too. So I couldn't follow her to see if she had babies everywhere. This was actually really cool to see. During the main season, I looked in the nest box and I was like, oh, there's a Phascogale, and then I radio tracked the other one and I was like, oh, there's 2 Phascogales in there. So I had a little look, and it was my boy and my girl, and they were sharing a nest box for that. So that was very cool. That was a very cool experience to see that. If you also look at this nest box here, it's very, very messy. So phascogales, if you're doing when you're doing a survey and you look through nest boxes, if you see a very messy one like this that has moss and leaves and feathers, you know it's a phascogale. Gliders have nice, clean eucalyptus, nice smelling. As soon as you open it, it smells lovely. That's a glider. They like to keep their nest boxes nice and clean. Whereas phascogales poop in it, they have carcasses in it sometimes. They're very messy. So that's how you can tell the difference between the glider and the phascogale nest. They do share nests, so like gliders do go in phascogale nest boxes and vice versa. But they tend to gliders tend to put more leaves on top of it, so it kind of becomes a layer. Yeah, we'll go to the next one. So in this area, I was looking for the tree lizards. So I was really tracking these phascogales to, first of all, see their home range, see where they're going, and to see what trees that they were using. So there was 3 main dominant trees in this area. The first one being a grey box gum. Second one, a slaty gum, and 2 species of iron gum. You can't tell them apart because they look exactly the same. The only time you can tell them is when they're young and they're growing. And
when they're flowering.
And then when they're flowering. But yeah, it's very difficult, and that's my partner doing the work for me. So, I should go back to that. So when we found where to track the phascogale to a tree, we would identify that species of tree and also take the circumference of that tree, so we could go back and see how big of a tree, what trees they were using, what tree sizes, and what specific tree. We'd also walked transects after we had the study. We did 700 meters throughout the Phascogales, each Phascogales home range. We did 3 of them throughout, and we were just measuring the random trees that they were using. Just trees in the area that well, we don't know if they were using or not, but the ones that we hadn't recorded them to be using, and then we would measure them and then record them just by the species and the stuff. So here is a diagram. So it is, I'll just make sure I get this right between the colors. All right, so the blue is the trees that the Phascogales use, and the red here is the circumference of the trees that they didn't use. So just random trees in the area that we measured that they didn't use. So the point and being here, so this was all fixes, both day and night. And here is the regression of the circumference and trees they used on multiple times. So like I said, Phascogales use trees multiple times. They use the same, they have different, they tend to change a tree different nights and they reuse them. So they had trees that they particularly liked. We had a Phascogale use a grey box gum 10 times. We also had 2 males share the same that same tree at the same night. So it must have been a really great tree. So I just wanted to see if there was a difference between the circumference and the species, and there was a significant difference. So here is showing that Phascogales selected trees that were significantly larger, you can see here, than the randomized trees. And this was for ironbark species. Oh no. Ouch.
I'm sorry, I was gonna go.
Oh goodness. So they chose trees that were significantly bigger, and this was for the ironbark species. Oh, just make sure he's dead. Oh, that would have been not fun. So Phascogales chose trees that were significantly bigger than the randomized setting. That was for the ironbark and the grey gum, but it wasn't relevant for the dead tree and the slaty gum. So slaty gum. Slaty gum. So that's a red gum, not the tree. Yeah, but then it's Davey smooth gum. So that wasn't the difference so they chose trees bigger for the ironbark species and for the grey box, but not for the dead tree and for the slaty gum or smooth bark tree. And so 54 den trees were used for all 5 Phascogales, for all 5 individuals. 44 dens were used more than once or twice. 10 den trees were used 5 times or more. And like I said, that one grey box gum was used 10 times. So, excuse me, sorry. So this is a graph of the proportion of trees used for each species. So if you go to the proportion, this is comparing the random sample in the area compared to what they used. So dead trees here are now the optimal tree. So dead trees had a higher proportion used. So to simplify that, if you had 10 trees, they would use 8 or 9 of those trees. So there was loads of ironbarks, but in proportion to what they had in the area, they didn't use that much. Dead trees was the optimal of the tree. So you can also see right at the bottom there that Phascogales did not occupy stringy bark trees, even though they had hollows. So all these trees that we measured had hollows in them. They were good Phascal any tree to know the difference between the tree that they chose and the trees that we sampled. They both look good, but they preferred dead trees. So they didn't occupy the stringy bark trees, even though they were available. So a possible reason for this is that the bark has shedding qualities, and maybe they don't attract enough invertebrates for them to bother eating or staying in, or maybe their hollows weren't suitable. Maybe gliders were using them instead. They had in Victoria, they had a study where they put nest boxes onto stringy bark trees and then Phascogales used them. So maybe it is because the nests aren't suitable. We don't know why they don't like them, but yeah. So like I said about the dead tree on the next slide, this tree here was our smallest tree. This was 80 centimeters in circumference. And if you look here, inside there was a Phascogale. So this tree, I spent so long looking for this Phascogale. There was trees that weren't big enough everywhere. And everywhere I looked, and it just kept taking me around here. And I was like, there's no possible, I can't see a hollow. It can't be in this tree. Like maybe he died. I was looking on the ground, thinking I was seeing a dead Phascogale somewhere. And then I just bumped. I was looking at this tree and I bumped into it and I saw that there was a crack and I was like, oh, I shine a little torch in there and there was a nest. And there, you can't see in the photo, but you could see the little tail of the Phascogale. So this tree was used multiple times. This was used like 5 or 6 times by this one Phascogale. He would always go to this tree. And it's perfect. He's got his nest in there. He knows where it is, and nothing really can fit in there. So it's perfect for him. So dead trees, they provide great habitat, not only for Phascogales, but for so many other species, even like snakes, squirrel gliders, like they're great habitat. So dead trees are very important. And that's the real main message I'm trying to push to the landowners is that they need to keep their dead trees. They not only there's a wedgie that loved this dead tree too. He was probably looking, it was a good vantage point for him. There was nothing in the way to stop him to look for any like rabbits around. So they're used by all types of different animals. So yeah, they were highly preferred compared to the living trees. And this is because dead trees, no matter how long the decaying is, they always have hollows. So it takes so long for a living tree to get hollows. They need to be a certain size, have certain bacteria, and that's what causes the hollow and decay. Whereas dead trees, they go through a decaying process and there's always going to be hollows. So that's why dead trees are so important. We'll go to the next slide. So why didn't Phascogales use the slazy gun so much? And if you have a look, this is a theory that was another author has suggested that why Phascogales didn't use smooth bark trees that often. And if you have a look, look at their feet. So their claws aren't curved. So these gliders here, if you look at his feet, I don't know if you can really see, he's got curved claws. And the curved claws might help them climb up the smooth bark trees. Whereas Phascogales don't have that, and it may make them harder to climb up the trees. Also with the lack of bark invertebrates, but they don't really care too much for the smooth bark trees, but they still did go onto them. They still did stay into the large trees and also the small trees, but it didn't matter for them too much because they didn't really use those guns too much or smooth bark trees. So it might be difficult for them to actually climb onto the tree compared to gliders. That could also be where gliders are nesting a lot, and they did. The gliders did den into the spade gums quite more than the gliders. We'll go to the next one.
Can I get your charger?
No, it's all right. So this is the species, the sexes wasn't significant between so the trees, sorry, I'll repeat that. This is the proportion of the count of trees that were used by each individual phascogale. So these were the 5 phascogales down here. So there wasn't any significant difference between the sexes, but there was a significant difference between the individuals. So as you can see, this one individual used the casuarina. I think he was at the point where he was dying. So he just chose any tree that was available to him. Like I said, males die in less than a year. So I think he was in that mating frenzy that he was just choosing trees that were around. I'm sure I looked in that tree many times and I couldn't find any hollows, but he did use it quite often. Like you see, the camel trees, they used iron barks quite a lot in the count, and that's because there probably was a lot of iron barks around since it is the iron bark bog forest. And dead trees, grey box, and sagum they used. But there's one male, these two here. So these are the two, the green are the 2 females, and the grey are the 2. You probably can't see from that far away, but these 2 here at the front, they're the females, and these 3 are the males. So the females and one male really use the iron barks a lot. So there was a difference, and that's just probably because of their home range. Maybe some phascogales only had so many species of tree in their home range. The females didn't really travel that far, and whereas the males traveled much further. We'll go to the next slide. And I'll show you that in this. So here is a kernel density estimate of 80%. I didn't have enough points to do a proper kernel density of 95. So I used what I could. So here was the different, each color is a different phascogale. These 3 here, so 1, 2, 3 are the males. So as you can see, they use quite a lot of the area. And these 2 here are the female. And they only have quite a tiny home range. So maybe when they were using the camel trees, maybe they're just using the trees that were in that home range. Maybe, we don't know. This is only a short-term home range, like I said. I can't, it was not long enough and didn't have enough points to do a proper home range study on the phascogales. But yeah, just a little insight on their home range. So the next part of my study was, do phascogales recognize cats as predators? Are they naive to cats? So feral cats pose a significant threat to many animals, and that's shown through the extinction of many animals on the islands and mainland. So brush-tailed phascogales fall into this critical weight range where they are most susceptible to introduce predators like cats. So the geographical range of phascogales, one of the main reasons for that could be the naivety of cats.
Next.
Yeah. So what is prey naivety? So that is when prey don't have decline because, sorry. So the prey naivety hypothesis suggests that cats cause prey to decline because prey species are either fail to detect them or don't have the anti-predator defense to defend themselves against cats or foxes or introduced predators in general. So as with most mammals, it is unclear whether they can sense cats. They have lived along cats for 150 years now, so maybe some animals, particularly small mammals who are most susceptible to cats, have this predator recognition that cats are dangerous. I don't know, we'll see. So I carried out a field experiment to see if Phascogales are naive to cats. And to do this, I use the sense of 4 animals. So I use the cat introduced, which is the introduced predator in this experiment, a spotted-tailed quoll as the co-evolved predator. So they know that quolls are dangerous because they've seen each other being eaten by quolls, or they just know just through evolution that they are a threat. I used Tasmanian devil sense, which was a historical evolved predator. They were on the mainland 3,000 years ago, so maybe they still know Tasmanian devils as a threat. And lastly, for the control, I used the possum set. So Phascogales see possums every single day. Maybe they aren't threatened by them. They just smell when they smell them. They're like, this is a non-predator. And yeah, that's what I used for my experiment. So I had 20 cameras randomly selected in this area that the Phascogales were used. So I had 5 scents for each animal, just randomly associated in this area. So there were a lot of limitations in this study. This was a pilot study, so it wasn't we were just testing to see if they did recognize them, and then I'm going to go on to film the study actually next few weeks to see their behavior in video, see if it's changed. So with the photo, getting a photograph of them, it was much harder to see their actual behaviors, but this is what I define them as. So the first image here is them approaching the bait. The second is smelling the scent. The third is sniffing or feeding. D here is if they're showing vigilance, if they're looking around. E is they're smelling the actual scent from the animal. F here was them exiting the frame, so they sniffed it, they looked around, and then they're going. And G here is them completing avoidance. So it's really hard to tell here, but going through the images, the avoidance, he just ran away. It could be that it was a delay and I didn't catch the first bit, but we'll never know because that's all I saw. And that's why I'm going to use video next time with the experiment. And that's one of the limitations to this study.
You should just use normal cameras that go off.
Yeah, the normal photos. Yeah. Next. So this is the delay in minutes for Phascogale to approach each scent. So as you can see, they are pretty similar. It shows that so the cat here, it took it roughly around 3.5 days for them to approach all the scents. Go next slide. This one here is a little bit of more confusing little graph. This is just the behaviors on each of the behaviors and how much they did it for each scent. So the main thing of this is look at the avoidance. So the only sense that they did a complete that they didn't avoid completely was the possum scent. So they avoided the cat scent at times. They just walked past. And same for all the other predator scents, except for the possum scent. They didn't do a pure avoidance for that. But the rest, they showed vigilance to. They smelled the bait. They ate the bait. Yeah. So, from this study, do Phascogales recognize cats as predators? Yes, they do. They showed vigilance throughout the study. So they showed that they recognize predators. They did the same behaviors to quolls, to cats. They also did the same behaviors to the possums. So maybe they consider possums as a large competitor. Maybe they just try to avoid them because they're just possums. And they might consider them as large predators. But more needs to be done on this, and that's what I'm doing in the next part. I'll be doing this experiment. I'll be taking out the Tasmanian devil because I know that they recognize them from their study, and I'll be replacing it with dog first. I'll be doing dog, cat, sugar glider. I'm replacing the possum with sugar glider because no sugar gliders are not a threat. Maybe the possums was too threatening for them. And I'm using spot out as the dogs.
What about foxes?
So in Mount Royal National Park, this is near Mount Royal National Park, foxes aren't really there. There are foxes there, but not as prevalent as dogs and dingoes and feral cats. Feral cats are the most there. Mount Royal has managed to wipe out foxes through the 1080s. So they've done actually a really good job with that. So in the whole 2 years taking photos constantly on this property, I only got 2 foxes. So I didn't choose to use fox scent because I thought it'd be better to use dog instead. Next one. So lastly, before we get to the questions, why is this research so important? Like they're just another Australian animal. They haven't really been studied, and that's why it's so important we study them. We need to know what is going on, what their status is, if maybe they're more than threatened now, maybe they're endangered. We don't know. Nothing's been studied on them. So that's the main thing. They have lost 50% of their home range. So sorry, of their habitat range in Australia. So we know that for fact. It's just decreasing just because of deforestation. And we need to help landowners manage their land. We need to make sure that they're not or they're preserving large growth trees as well as keeping dead trees and keeping those younger stands. We need to make sure that land management really goes back into this species as well as other broad species. If we help protect Phascogales, that will lead on to protecting sugar gliders, squirrels, and other animals in this area. So this landowner, she's done a great job at preserving her beautiful land. She's done great land management. She cuts down trees only, she selects them only if they're like at a certain age, and she very rarely does that. Her grandparents and her dad preserved it, so I'm very thankful that for them too for looking after their natural environment. And I acknowledge her in the next slide, which I thank everyone. Jan and Ralph for looking after their property. Thank you for the Oakley, sorry, I don't say it wrong. Oakley Fauna Conservation Society for helping me with my grants. You really appreciate those colours. That all helped for that. Featherdale and Australian Wildlife Park for giving me the sense. And my beautiful volunteers who all helped me with the study. I had countless volunteers. Any questions? Yes.
Yeah, pick up the voice. Just so they can pick up the voice. Area extensions. Water conservation, national park, state forest, and so on. Did you know of any studies that's been done in one country like that to see if for some reason they had a dense population of Phascogales in this smaller area, semi-natural farm, ex-farm country compared with forestry or national park? In other words, you think there might be Phascogales beyond where you are, or is this unusual?
So that I really wanted to do that. I just didn't have enough time. So master's only 2 years. If I was going to do a PhD, I would have compared 2 different sites. In personal experience, just from the landowners in that area all talking to me, this land is great. There is, if you go up more north, so actually near Foster and Southwest Rocks, there's meant to be a dense population of Phascogales living there just because of the spotted gum ironbark forest. They only tend to really live in spotted gum ironbark forest. I should mention that there's only 10% of spotted gum ironbark forest left in the Hunter Valley. So very small, and that's the only real forest that Phascogales live in. There could be more around. There's definitely needs to be more research on Phascogales in New South Wales. Like I said, I'm only the first, and this is only a very brief little study in this agricultural environment. So it's very niche, but there definitely could be. We just don't know. We just need more people to be interested in researching them.
Secondly,
Yeah.
you had access to data or not, talking to people in Victoria where there's still Phascogales in various ways, like scaffolding reactions, so even over in WA, where
Yeah.
in other words, have you managed to do any comparative studies on the data that other people may have done, or what should be groundbreaking, absolutely?
No, there's definitely people who have done similar things to me. Mine is mainly related to land management in agricultural. First of all, most studies don't really go into the agricultural lands, they go into forestries or fragmented habitat within around agriculture, where this is actually a beef farm. Like they have cattle on this property and they use it for farming purposes. So I just really wanted to see this property as a whole, because I just think it's amazing how she's managing this property so perfectly. There's things in here that's not great. Like she never overgrazes her property. She rotates her cattle. And I just really want that to be a thing that you can have agriculture living with native wildlife. She's got screwblash, she's got quolls, she's got Phascogales, and all that in a beef farm. So that's really what I kind of want to put out there in land management wise, and how to survey them in everywhere, but more mainly in areas that are fragmented. That have been there's less quantities of less density of Phascogales in the area. But my research is really only to do with that, and no one's really done that. No one's really stepped into that, mainly because I haven't probably had access. Whereas, yeah, so I wouldn't say it's really groundbreaking. It's very similar, but yeah, it's just it's just.
I've never read anything in Victoria, Queensland, or
About Phascogales? Oh, there's loads. Yeah. Todd Soderquist. He does loads of Phascogales in Victoria. His whole PhD, and Susan Ryan. Yeah.
Parallel studies with yours.
Most of them are in native or around agriculture. No one's done agriculture for Phascogales in general. There has been a study in the same property on quolls. That's why I got in contact with the council, and they knew this land, and that's why I kind of got in contact with them for that. I was really interested in how this is possible, really, and that's what I studied. Yeah.
Just like I went with her, and all the properties surrounding it in a field, there'd be 2, 3, and 5 trees, and the property we went to, trees everywhere. So it's like the surrounding farmland is not.
It's just the way they used to be. They used to, yeah. It was, yeah. It literally, it was very sad to see, but I'm very grateful she and her generations before her looked after this property. It was beautiful. Like the amount of wildlife on it is amazing. Very unusual. That's why I kind of was looking at that, because I wanted to see. I was going to compare other areas that were cleared. That's what I was going to do if I had enough time. But I kind of thought there wasn't really any point, because I'm going to spend all this effort doing that, and there's not going to be any Phascogales there because it doesn't have the right environment. But yeah, it is an oasis, and there are farms in that area that have contacted me after I have done this, and they're like, "Oh, we have Phascogales on our property. We've seen a dead one, and we're really interested in what we can do to help them." So I'm hoping that when I publish these papers, they'll really go into land management more than anything. Yeah. Yeah.
What age would they be,
yeah, almost. I think it's about 3 to 4 months. A male, and yeah, they're reproductive in their first year. So they're born. This is just a rough estimate. Let's say the main season's between May to July, and they tend to die off around July, August. It's very rough. So they mate in June, around, let's say they mate in June. A few weeks after, not long after that, they have their babies. In November, they disperse. Around November, they disperse. So they stay with their mum for a long chunk of time, like 2 months. So that's a lot of maternal investment for a little thing. So that's why I was saying that maternal investment could be the reason why she spent so long in trying to get the bait. And then when they disperse, that's when they're ready to mate. Basically, as soon after that, they're mature, and then they do the mating season in May. So literally in their first year, and then they die. So the reason, so the reason why people think that Phascogales they mate, and I think they get into the big frenzy. Their little bodies can't handle it. Same as Antechinus, little bodies can't handle it, and then they just die. So they don't have a very long life, and females. There was a captive male Phascogale who lived for, I think it was 2 to 3 years in captivity, who hadn't mated. So I think it's just because their excitement. And then females tend to live. They could have their second litter. It's very rare for them to have a third litter. Their maternal investment. They just die.
How many would they have?
They could have six to, I think it's 6 to 8. So they have 4 teats. Yeah. So they hang on to them for 5 weeks, and then they drop them into the nest, and then they look after them for a few months after that. And yeah, they can have quite a lot of babies. Yeah.
Thanks, Coop. Sorry, Jay. Did we
Yeah.
hand over?
Yeah,
Sorry.
it's great. I've had a Phascogale in those 2 years.
Oh.
But anyway, the property was completely isolated from the forest. No
corridors. I was thinking that, I was like, oh, it's so close to Mount Royal.
So how
Maybe
close to the next bit of forest? Like, yes.
it's far. A Phascogale couldn't travel from Mount Royal, because Mount Royal is probably the only real big forest. And Phascogales, they like the lowland. They don't like the high. So when it gets to higher altitudes, they don't really like it. That's when it gets to rainforest. They don't like rainforest. They don't have to get their little paws wet. They like the dry iron bark, dry spherical iron bark.
Friend has traveled coast on ridges, ran across Calcus. But anyway,
that's really cool. Yeah.
Is that did you get a rough estimate of the home range of the females and males, and were female home ranges discrete from each other? Like separated, and males overlapping, because that's what I found in quotes. Females discrete and males overlapping.
So with that question, males do overlap.
Yeah.
They overlapped quite significantly. Yeah. Like I said, there was 2 males in 1 tree on a night, so they do overlap. And females were quite yeah. I only caught 2, so I can't tell exact from that, but they were quite distinct. And females was roughly around 5 hectares. Mm-hmm. Males was roughly around. Sorry, my computer died. It was bigger, significantly bigger. It was probably around 20 to 40. This is kernel density. Yeah, it was quite bigger. Yeah. But in comparison, in Victoria, in a low quality forest, Phascogales females would have a home range of 41 hectares, and males would have 104 hectares. This is in low quality forests. In high good quality forests, females had a home range of 5 hectares.
Mm.
So I'm not saying that this is good, but soil comparison to that, it's showing that this is quite good forests from the smaller home range of the females.
So large remnants by agriculture may play an important
100%. I 100% agree. Like that, if you help nature, you can have, as long as you look after it, you can have native animals living in agriculture. I definitely believe that from this property. Yeah.
Fascinating topic. One last one, Doug.
One last.
Yeah.
Yeah.
Have you got shots with any of your horizontal cameras of female technical young?
Yes, I do. I don't.
Why didn't you on the ground?
She was on the vertical. I could only see on the vertical. Because the way the vertical was tilted, I could see her. She had 6 babies, 6 little. She could have more. She could have had 8. I'm not entirely sure. I just saw that she had 6 pink beans on her. I didn't see her with the young, because I finished mine in before they would leave the nest. I finished the study. But yes, I could see she had young attached to her.
You never actually seen a shot of female being followed.
No, I didn't. No.
Yeah, when you said the young father about the I thought that would be a great shot.
It would have been great, yeah. I recently bought my camera kind of died during this study, so I don't actually have any great quality pictures of the Phascogales, and I just recently got a new one. So I kind of want to, when I start this next study, that's really not related to my master's, just kind of just a fun study that my supervisor and I kind of want to do. I hope they get some good shots. Yeah, that's what I hope. I hope people, the next lot of people, hope they're interested in doing something with Phascogales, especially in comparing forests to agricultural landscapes, because that would be amazing. It's just time, and we need more people.
Thanks, Lisa.
No worries.
Fascinating topic. Janine,
Oh.
vote of thanks from.
Yeah, from all of us tonight, thank you, Lisa, for a very informative meeting. For many of us, I think not too many of us have known much about Phascogales, and we admire your persistence in chasing these little devils around the place, up the trees and up the ladders and all the rest of it, to present a fascinating look at their life and their housekeeping skills and all the rest of it. So we really appreciate your time tonight, and thank you for putting up with the technical problems, but for the rest of us, it was very informative. So thank you so much for your time and what you've done in the future.
Thank you. Thank you. See, I know it was a bit of technical difficulties, but I hope you got to see something on the screen.
Lisa,
Yeah.
would you be able to put your talk to a website or onto one of that?
Do you want my presentation? Yeah, I can
Just
show it.
presentation.
Yeah, that's it.
Would it be all right? Would it be all right to put it on the website?
100%. You can put it. Yeah, that's all good.
Right.
Yeah, that's all good. I can. The USB is there, so you can just pass it around. And I'll put it. I don't know how to. Don't want to impact it. Is this still on?
Is this still on?
Alrighty.